In this video, I will explain a bit about object-oriented programming, classes and objects, and a few basic Java functions. I will be using the Eclipse IDE. Let's start by creating a new project. Create a Java project, we can give it a name, and then for now, make sure to uncheck create module info.java file, just because at the beginning of the course we will not be bothering with that, and if you don't uncheck it, you would have to fill out some settings, but that doesn't matter for now. So just press finish, and we have our first project. So now open it up and right-click the source folder to create a new Java class, and we will call this class main. For now, let's leave the package field empty just so we don't have to bother with that. I will explain what packages are in the later video, and uncheck to add public static void main if you haven't already, and then you can press finish. And now we have created our first class in Java. But what are actually classes? Well, Java is an object-oriented language, which means that everything in Java will be revolving around objects, which means we will have actual things. Let's say you can have a cat, you can have a dog, you can have a window for your GUI, and those things can do other things with the use of methods, or also called functions. But to actually create our objects or the instances of our objects, we first need to have a class of that object. You can think of classes as kind of templates for your objects, which are actually used to create the instances of that object. Before we expand on that, let's just create a simple hello world program. As you can see, I added a main function inside of our class. Let's quickly explain what they actually write here. Public is the keyword for the access level of that method. We will expand on that later. Static, I will explain in a second. Void is the return type. Void means that our method or our function is not returning any value. And then in the brackets for arguments, we have a string array. That's how you define a string array, called args, which is basically where all of the Java arguments will be stored in. If we want to print out text to the console, we can do so with a command called system.out.println, and then in quotes you can just add your text. Don't forget a semicolon, and our first hello world program is actually already done. So we can try running it, and as you can see in our console, we can see the hello world text. But what we've done so far doesn't really seem like object-oriented programming. It seems more like a scripting language or anything else, because we didn't even create any objects or we didn't even use any other classes. So let's expand on that now. Let's create a new Java class, and let's say we will call this one chocolate. So we can right-click our source folder, create new class chocolate, and we will leave package empty again, finish, and we've created our chocolate class. So now let's think of this as an actual object we could have. So first off, what information can you store about chocolate? First, we could store the type of the chocolate. So let's say we're gonna have an attribute of type string called type. This will be the type of our chocolate. Then let's say we're gonna have an integer of the amount of cubes in that chocolate. And let's say we'll just add another string for the name of the chocolate. So these are our three attributes. So let's just leave it at that for now. And we can go back to our main function where we can now use our chocolate object. But first, we have to create the instances of our object, because as I mentioned before, a class is kind of just a template to use to make the actual object. So let's erase our print line, and to create a new chocolate object, we can simply type chocolate as if we're using it as an actual type of a thing. Let's say we will call our first chocolate choc1, and then to actually assign a new instance of the chocolate object, we have to use the equal sign and then the keyword new chocolate. And that's how you create an instance of an object. So let's create two more of these. And now that we created them, we can actually update their values. So let's try to change our choc1, and to access its attributes, you simply use the dot operator, and then as you can see, Eclipse even highlights for us all of the attributes which we have access to. So let's set the cubes to be equal to 10. Let's set the name to be KitKat, and let's set the type to be milk. Apparently it's a milk KitKat. And that's how you would update the public attributes of an instance of an object. And one important thing to notice is that every single chocolate we created, choc1, choc2, and choc3, are separate things with their own separate data, which means that if we set the cube's name and type of our chalk1, our chalk2 and chalk3 still don't have it set. So just for an example, let's set everything for chalk2 as well. And let's remove chalk3 because we don't really need it. So now we have two chocolate object instances, one which we called KitKat and one which we called Mars, and they have their own separate data. You can access that data with the same way we just set it. So let's use our systemout.println to actually print out the information about our chocolate. Let's copy it over. As you can see in Java, you can easily concatenate strings, at least when you're printing it to the console, by simply using the plus symbol and then the name of the attribute you're using. So if we run the program now, you can see it prints name KitKat, type milk, name Mars, type coffee. Just as we expected, chalk1 and chalk2 are actually separate objects with their own separate data. But the way we added the information to our chocolate is kind of annoying and unnecessary because we had to type it out to set everything separately, while there is a method to just set all of those attributes while you're creating the new chocolate itself. So we can go back to our chocolate class, and we can do that now by first off setting all of our attributes to private. And setting them to private means that our main class can no longer directly access those attributes. But this is the proper way to do it, and I will show you in a second what are you supposed to do in that case if you can just access them. But let's start first with the thing I mentioned about setting all of the attributes while creating the object. To do that, we have to create a constructor. To create a constructor of a class, you can simply use the name of the class, so chocolate, and you can actually create many different constructors because a single constructor is only handling a single case. In this example, this is an empty constructor because it doesn't take any attributes, which means that it will be used whenever you create a new chocolate object and you will not pass it any attributes. But we have three pieces of data which we want to set. So let's change our constructor to actually take in that data. String type, string name, int cubes. And then inside of our constructor is all of the code that gets executed once you create an instance of an object using that specific constructor. So at first we have to set all of our object attributes to actually be the same ones which are passed into our constructor. To do that, we can use the keyword this, where this actually refers to the current object we're working with. So if we're working with chalk1, this would mean chalk1. If we're working with chalk2, then this means chalk2. So we can access it the same way we did before. This.type equals type, which we passed in as an argument, and then we do the same with the others. This.name and this.cubes. So now we can go back here and we can remove all of those lines, and then we can actually use our constructor which we created. The order was type, name, and cubes. So let's set type, name, and cubes. And as you can see, our new constructor is working as intended. But now we have another issue because we made all of our attributes private, which means we can no longer access the name and type when using the println command. And now we have to do it the proper way. So let's go back to our chocolate class, and below our constructor, we will create some setters and getters, which will be used to manipulate the attributes instead of accessing them directly. This will just be simple methods. So let's create our first one. Let's make it public so that our main class can access it. And the first one will be our getType function. So it will be returning a string because type is a string. And then let's just call it getType. And inside of our getType function, we will simply return the type. As you can see, we don't actually have to specify this.type because Java will automatically assume that that's what you mean and that you're trying to use the object's type. Here we had to actually specify because we had an argument which was named with the same name. We can do the exact same thing for the two others. And now we created our getters. So let's get back to our main function now, and let's replace our direct access to the attribute with our method. But the methods have to be called from the object itself so that Java knows which objects we're talking about. To do that, you simply use the name of the object, just like we did before when accessing its attributes. So it's going to be chalk.getName, chalk.getType, And if we run our program again, we get the same output as before, but this time we're actually doing it the proper way. And just as a proof of concept, let's create one more function, which I will call, which will be public. It will actually return void, which means it will not return anything, and it will be a setter function. So set name. And in our set name function, as you can guess, probably we will set the name of our object to a new name. But to do that, we have to pass an argument, string name. And as we're passing an argument, we have to use the keyword this now. And that's our setter done. So we go back to our main function. And after we create our object, we can now override the name of our chocolate. So let's say that choc1 dot set name, and we will call the new name. If I run the function now, as you can see, the name of our first chocolate changed to Twix. So now one last important thing I want to cover is the actual keyword static, which we mentioned at the start and which is used in our main function. What static does is it actually makes the attribute or the function which you added to be associated with the class itself and not with a specific object, which means that if you make a static attribute, it will be common or it will be the same between every single object you create, and it will not change on an object by object basis. We can demonstrate that by creating a new attribute. Let's say it's private static integer chocolate count. And at the start, let's set our chocolate count to be 0. And now what we could do is we could create a method which increments our chocolate count, but we already have a method which we can use for that, and that's our constructor. Our constructor is used every single time you create a new instance of the object. So after our assignments, we can just go chocolate count plus plus, and this will actually increment our chocolate count every single time you create a new instance of the object. To see that, let's make a getter function, public int get count, which will return our chocolate count. Or actually, just to be a bit different this time, let's make it so it returns void, and instead of get count, we will call it print count and just use system out print line over here. System current count is chocolate count. But if we do it this way, we would actually have to use a specific chocolate like choc1 or choc2 to call this method, and that's not what we want. So let's also set this method to static, so that you can just call it from the class itself. Public static void print count. Now we can go back to main, and at the end of our program, we can simply go chocolate.print count. And if we run the program one last time, as you can see, our method works perfectly. The current count is 2 because the constructor incremented the count of our chocolate. And that would be it for this video. Thank you very much for watching, and I hope you tune in for the next time.